Hello, everybody. This is Tolga from Dijitalis, speaking from Istanbul, Turkey. My session today is titled Investment Planning with Long-Term Capacity Simulation. But before starting my presentation, I would like to introduce my company first. As I mentioned, we are based in the beautiful city of Istanbul. And since our inception in 2006, we provided simulation and digital twin services to more than 150 customers with more than 400 projects. As well as in Turkey, we also help the customers in 13 different countries. To give you a better view of our services, in a nutshell, we want to maximize the value that our customers offer their own customers through building some new capabilities, such as the supply chain strategy and supply chain design, as well as utilizing the assets better and optimizing the processes. These encompass the whole supply chain, from end-to-end supply chain to production, the warehouse, and the logistics. That's why actually we call ourselves digital twin experts. Our expertise are from end-to-end supply chain studies to a detail of a single facility for the material flow and interlogistics. Again, for a single manufacturing site to simulate the production lines and the new automation ideas such as the conveyors, AGVs, and robots. As well as we go into much deeper detail for a simulation modeling and building the digital twin of a single machine. So in addition to our projects in Turkey, we had the privilege to help other industries in different countries, from Europe to Asia, from Middle East to Africa. So let's start with the business case, which started this simulation project. Our customer produces state-of-the-art steel pipes, addressing all areas ranging from automotive to construction, energy to machinery production. With its 7 facilities across 3 continents, the company achieved success, which is acknowledged by the American metal market for the best pipe manufacturer in 2015, 2017, and 2020. The company is looking for a capacity planning solution to decide on the investment budget on an annual basis. However, considering only the production capacity for this industry was not sufficient. In addition to the production capacity, storage and handling processes should also be considered, because any deficiency in that kind of capacity would create a bottleneck that will eventually reduce the production capacity which is available normally. So to give you a better idea of the complex situation in that company, so first of all, the product portfolio diversity was large, and the factory was producing in batches. And because of the process constraints, when added to that complexity, generate considerable amount of work in progress inventory. And that inventory was stored on top of each other as a pile in the factory floor. And since the limited storage area in the facility, sometimes they need to move the pipes to a faraway location. And as well as the storage zone problems, the piling also generates an additional situation, because the piling and depiling of the pipes requires a lot of crane activity. Also, in the top of the normal production process, quality problems downstream would create reverse flows for rework, and then the produced pipes will be again handled by the cranes and taken back to the upstream processes. So to sum it up both the reverse flows and the piling and depiling operations requires crane capacity, and storing in faraway zones would increase the transfer distances, and these all result in a logistics capacity problems. Therefore, the production goals are tackled by two different capacity constraints: production and logistics. Therefore, an integrated approach to the production and logistics capacity was required, and the solution was building a digital twin of the factory. During our study, the simulation model shows the intensity of the situation, that the crane productivity is very much dependent on the inventory level of pipes. So you see that actually, if you have only one level of pipes on the storage area, the picking time by the cranes are relatively short. But if you place two levels of pipes in the storage zone, then a slight piling and depiling operation happens, and the average picking time for the pipes is doubled. And as you are producing in a batch production, and because of the process constraints, sometimes the inventory builds up, and with the limited storage zone, the company needs to have 3 levels of pipes. And this again increase the picking time per pipe to even more higher levels. So the simulation showed us that if there are 2 levels of inventory in the storage zone, to pick a pipe at the bottom of the pile, the crane on average needs to move 2 pipes. And if 3 levels are allowed, then to remove the bottom pipe, 5 different moves had to be made by the cranes. And when you compare this picking times from the storage area, you can easily see that it is, if you exceed one level of storage, you are exceeding the takt time of production. Therefore, increasing inventory creates some starvations on the production machines, because the cranes cannot move the pipes on time, either leaves the next machine start or leaves a built pipe on a machine and leave the machine as blocked. So the approach was to build a simulation model with all the production and logistics rules and constraints. So this model was used in 2 different ways. One is that we imported the yearly forecasts so that the company can run a whole year of simulation to understand where are the bottlenecks and what should be the investment budget to remove those bottlenecks, or a more short-term analysis for the monthly orders to decide on the shift and inventory planning rules. Here I would like to show a video of the simulation model, and to give you a better understanding of the efficiency of the simulation modeling, you could see that in this model, 12 months of production simulation based on forecasted orders only takes 15 minutes to run. So for a few minutes, I would like to leave you alone to enjoy the simulation video. Here, the simulation model runs 12 months of production orders. As you can see, the raw materials are moved to the first processes, and then the semi-finished goods are moved by the cranes or forklifts to the storage zones. And likewise, then the semi-finished goods are moved from one process to the other one until it is stored in the final storage zone. And by running these 12 months of forecasted orders, the company could see the utilization of all the machines in the factory and see which one is going to impose some problems for the production and which resources will be bottlenecks, so that the company could understand where to invest and how much. And here, more importantly, you could see the inventory buildup in different storage locations with a breakdown of different product groups. As you can see, the timeline is coming from 1st of January until end of the year. So day by day, it is visible that at what time the storage zone capacities will be exceeded, and then the cranes or the forklifts will start to move the pipes to other regions, which are less favorable because of the distances. It is also important to measure the utilization of the overhead cranes to see if any of the cranes will be a bottleneck throughout the year. Another important measurement from the simulation is showing the 7 main production lines, and it tells the capacity loss due to the factory logistic reasons. So we are measuring here what will be the capacity loss due to the overhead crane bottlenecks or the storage location capacity bottlenecks. And finally, here we see what will be the annual production of this factory and how it compares with the forecasted orders. So let's review the results in more detail. As I mentioned, from the simulation, we could see the utilization of all the production resources and the activities, such as the idle time and what other activities the resources are used for. Again, we are able to see what will be the utilization of the material handling equipment, such as the overhead cranes and the other transportation equipment. Here, again, we could see the storage zone utilization and how much inventory is building up where and from which semi-finished good. And here we have the general results showing what should be our expected production capacity under this investment level. Of course, by running these simulations, we were also able to show better rules to manage the production. By running extensive simulation experiments, we were able to show what should be the optimum inventory level in certain storage location so that the bottleneck is not the overhead crane. And here you see a combined improvement ideas for this factory, showing that what should be the total number of pipes that should be stored in certain location, and what should be the number of cranes working in a certain hole, and when should we program our reverse flows so that it doesn't cannibalize the regular production flows. So these are also important rules that we were able to optimize thanks to the simulation, so that the company can implement these rules to better run the production. As a final word, I would like to say that if you need a digital twin expert on your next project, we as a Dijitalis is in the middle of the world. The reason I'm telling you this is that from the left-hand side, you could see all the business, the commercial and the leisure flights, and how it intersects in the shown cross line. And this is where we are based in. So we are at your disposal with our geographical proximity and time zone convenience as your digital twin partner. I would like to thank you for listening to me and waiting for your questions. Thank you very much.
Well, thank you, Tolga, for a great presentation. We have some questions for you, a lot about the cranes you used. So I will start it off with, are the pipes picked up with some priority or other logic, or are they picked up by the cranes at random?
Very good question. Actually, we are taking into account the production plan of the factory. So each pipe has a deadline for the delivery. So we are taking it into account while picking the next pipe by either looking at the order priority or the due date of the order that pipe is relevant to.
Okay. Another question diving into the cranes. How did you implement the custom details pertaining to the crane, like different picking times depending on what is picked?
Again, a very good question. We need to build a very precise model because the picking time is really dependent on the fact that if there is a piling or depiling necessary. So we had an inventory data table that's recording the position of each pipe. So by looking at as I mentioned, for the production plan, we decide on which pipe to take from the storage zone if it is in the bottom of the pile. So we are looking at the pipes, and one by one we are depiling it and looking if the storage area, where is the next available place to put the pipe. So it was a really precise model which is looking into the inventory addresses for each pile.
Yep. Thank you. You had some great animations in your model. Can you speak more about adding animations to the model objects? Do you use open source 3D symbols?
For some parts, yes. For some parts, we use the SketchUp software to build some primitive geometries, but which really resembles the production line of the customer, because in the video probably you noticed that we are looking from far away at the factory place, where you could really ignore the details of the production line. So we use the very basic primitive object to build the customer's production line. But it is really important that I should emphasize that the geometry size needs to be small to run a smooth simulation model.
And with your model too, how often is your model updated?
Our customer is running the simulation model for each month, and also in the beginning of their budget preparation once a year for the whole length of the year, like 12 months of forecasted orders once a year, and for every month they run it for the monthly orders.
Yeah. And with your model too, did you identify bottlenecks in the processing using the model? If so, did the model provide insights about how to alleviate the bottlenecks?
Yes. So we run many experiments with the given production plan, and therefore we were able to deduce some rules to better run the simulation model, such as constraining some storage areas so that they are not really putting lots of pipes into that storage zones, or we helped our customers to define the roles and responsibilities of each crane, so that there is a balanced workload between each production cranes. And these were not able to diagnosed before the simulation run. So simulation really helped them to find out the best rules to implement in the shop floor for a more smooth production.
Hey, Puka, one final question for you. I think, how flexible is this model? That is, how easy is it to modify the location of cranes or other requirements and constraints?
Well, actually, there are two versions of the model. One is a data-driven model, which is very flexible, that the customer at any time could add some new production lines or change the operation zone of a crane very easily, such easy that it's like updating an Excel file. But of course, there is one version of the simulation model, which, as you show on the video, with all the 3D replication of the factory floor, which is sometimes important, so that the planners are really able to tell their ideas to the top level management. So the mathematical model is very flexible, but to implement the changes, such as adding some new production line, so for the 3D model, you need to make sure that it is in the right place.
Well, thank you so much, Tolga, for a great presentation today. It was awesome. Thank you again for participating in Simio Sync, and we'll see you again.
Thank you. Thank you very much for.
Yeah, we'll see you tomorrow too.
Yes.
Have a great rest of your day.
Thank you. Thank you very much. Bye bye.